Hi, everyone, and welcome to another webinar by Monogoto. Thank you for joining us. My name is Liran Adlin, and I'm the Senior Marketing Manager at Monogoto. The topic of today's webinar is the future of roaming and radio sharing over private LTE or 5G. This is a part of the webinar series, The State of Private LTE and 5G. So we see a vast growth in the demand of private networks. More and more enterprises are building private networks for their own use cases. And today we will cover many of the benefits and opportunities 5G and private LTE hold, and we'll present interesting use cases. Our host for today is Mr. Maor Efrati. He's the co-founder and CTO of Monogoto. Maor has 25 years of experience in building cellular networks, clouds, and internet applications. And guys, the last 10 minutes will be dedicated to questions. You can feel free to ask questions in the Q&A section during the webinar session. And don't worry, in case you missed any questions, you can contact us after the webinar via our email or the website. And now, without further ado, I'll pass the mic to Maor. Please enjoy.
Hi, guys. Nice to see some of you again and some new guests that we have in our webinar series. We start with webinars on the state of IoT. We moved to webinars on private network and private 5G. And today we choose a topic that it's a little bit more advanced, assuming IoT is available everywhere and everybody are adopting it, and assuming private network is starting to grow and private 5G and private 4G becoming a commodity, what's going to happen with roaming? We are seeing in the market a few trends. Some trends are to do radio sharing with various ways. And we wanted to take this next 45 minutes to talk about how we see the market, what do we see on the market in terms of roaming between public and private, or guest on private network, and a little bit in the end about what Monogoto can offer in this space. So feel free to ask questions in the chat. We'll try to answer questions in the end. Whatever not, we'll be very happy to take it offline. So we'll talk a little bit about recap on why to do private network, and then we'll move and focus in the type of radio sharing. Historically, DAS and Wi-Fi offload, and more futuristic, it's MOCN and roaming. We'll talk about the relevance of edge, and we'll see how, at least in our opinion and according to what we see the market, how a future service provider is going to look like, and example of how we see a possible future for service provider in hotels, and how roaming will play a critical part there. So just to recap, private 5G is going to be amazing. Private LTE, it's already amazing. I was just in an office building that we deploy a private 5G, and with one access point, we cover a whole floor, and Wi-Fi was like 16 different access points to cover the floor. So 5G or private networks on cellular have big advantages on Wi-Fi in various areas. The biggest one, in our opinion at least, is the spectrum efficiency of cellular. It's much better. It's licensed technology, and it can give much better performance. We always like to compare it. It's like a road without tollways and traffic lights versus a road with tollways and traffic lights. When you have tollways and you have traffic lights, important traffic can get priority, and it's not the same air for everyone. On top of that, private network will allow reliable low latency, will allow us to be able to replace cables, allow us to have density of many more devices, will allow us to do completely seamless transitions between public and private, will allow us to improve our cyber posture, to have better security, better over-the-air security, and better security in different slices. So I will be able to have multiple different networks that are completely isolated on the same air interface. Higher bandwidth are going to also be important and very relevant in in private 5G and private LTE. And eventually, we see a trend that factories now and campuses are already looking for replacing some of the infrastructure or adding infrastructure on private, and eventually it will even be more commodity to have my own private network. So with more and more companies and more land grabbing on private network, there is a question: what will happen with roaming? Just to add, private network are being deployed in 3 different frequency bands, and each one have different quality of service and different best practices. The sub-gigahertz band is great for utility companies that building private network. It's great for very long coverage, very low throughput, mostly CAT-M devices or NB-IoT devices, but can travel very far. The sub-6, it's the more dominant private network band. More and more governments allowing the sub-6 as a band. It's easier to allow it per location because of the characteristic of the sub-6 band that they are not traveling too far. So it's higher throughput, lower latency, but the range is medium. So it's very easy for a regulator to decide that they are taking a sub-6 band and allocating it to a factory or to a campus or to a store. More futuristic and will definitely be relevant is the millimeter wave, when we will get a much faster bandwidth throughput and much lower latency, but devices are not really out there. So this is why we think it's more futuristic. And at the moment, companies are more focusing to deploy private LTE on both sub-gig for 50 megahertz or 900 megahertz or sub-6. So let's assume that in an ideal world, more and more companies deploy private network. Starbucks can create their own private networks, and hotels can create their own private networks. And now we are coming to a topic that is very relevant, and the industry keep debating on it, and it's radio sharing. So we'll cover now a few types of radio sharing, how radio sharing is being done traditionally, and how radio sharing is going to be done more in the near future and maybe far future, and what we think about the best solution. So on the macro side, radio sharing was MOCN or MORAN or neutral host, and this is less relevant for private network. We'll cover it just for a minute to align our terminology. But when an AT&T and T-Mobile and Verizon wants to share the radio, they can share the radio in a MORAN or neutral host. MORAN is I have a radio that is my own, but all the other infrastructure is belong to someone that is hosting us. MOCN will cover in more depth later on, but the radio is shared and the core is different. And neutral host is a company that is not AT&T, not T-Mobile, and not Verizon, that decided to build a radio and publish it as a neutral radio, and all operators can get equal part on this radio. This is relevant for operators, is very relevant for how macro networks are being built, is less relevant on private LTE or private 5G. So what will happen in private networks? In private networks, we can even think about it a little bit historically. There was no radio sharing. So historically, when the subway in London created a private network, they did it on Wi-Fi. And when they did it on Wi-Fi, they already did an agreement with the operator that when a user of Hutchison is getting to the subway, he will automatically get service from the Wi-Fi. So we call it Wi-Fi offload, meaning I'm offloading the Wi-Fi, the cellular traffic towards Wi-Fi. That's one solution. We'll touch it in depth later on. The other solution that become more and more popular is DAS, distributed antenna system. And then we have more futuristic solutions that the whole industry is really starting to deploy, which is the MOCN and the roaming, and we'll cover it in the rest of the presentation. So let's start with Wi-Fi offload. And this is history, but this is still happening. I don't know about you guys, but me personally, I never got a good Wi-Fi roaming user experience, nor in the subway or in a shopping center. So maybe I tried a few times in the past to get to a shopping center and connect to the Wi-Fi. It's a very manual way that I need to do it. And even if I have operator like Boingo and Boingo have agreements with the other operators to create Wi-Fi roaming, still the user experience of Wi-Fi in a shopping center, at least from the information that I have, was never amazing. Maybe to be a Wi-Fi guest in enterprise, you get better user experience, but then it's harder to do the authentication with the operators. So regardless to the quality of service that we can get from such solution, let's talk what's needed in technicality. So company like Boingo that wants to do Wi-Fi offload in a shopping center needs to create a AAA pipe to AT&T, T-Mobile, and Verizon. And then when I'm getting into the hotel or getting into the mall or getting into the shopping center or enterprise, I will not need to configure Wi-Fi username and password because my SIM credential will allow me to connect to the network automatically. This is a solid way to allow me to be a member of a Wi-Fi network. It's using the SIM security, which is very legit and very good, but it's a Wi-Fi network with all the security problems and all the questions around the performance. So to summarize, Wi-Fi offload is a solution that is working. I don't think how scalable it is, and I don't know how robust it is to give service. The other thing about Wi-Fi offload is that it will only offload my phone. So I don't know what about my car, if the car will get to the shopping center or if I will have scooters or other type of user, not. So to summarize, Wi-Fi offload is here. Wi-Fi offload is available for a few years. Some operators like Boingo can do it with different MNOs. It's very popular in shopping center. It's popular in subway or in underground, but at least from what we think, it never got to a level of SLA and a level of quality that is suitable for someone to really work, especially if it's IoT device. So maybe less relevant for IoT. So then, in the last few years, more and more buildings and shopping centers and other locations deploy a different method of providing coverage indoor in an enterprise. It's not exactly a private network, but it's DAS, Distributed Antenna System. Meaning, if I have a need to provide coverage in a shopping center, I don't trust the operator to provide the coverage in the shopping center. So I will install repeaters, and those repeaters will take the signal from outside in various ways and populate it indoor. DAS will allow me to have what we call 5 bars. 5 bars meaning I will have great reception indoor. It's a very expensive solution, but it works well. And thanks to DAS, I can come to an office building today and go to -6 with the car and I can still be on a call. Everything will work seamlessly. My car will stay connected, a scooter can stay connected, and even my phone will stay connected. We'll compare it to other technologies. DAS is not simple to implement, and DAS is not cheap, but it definitely do the work of extending the cellular network indoor. Then this is the new kids in the block, MOCN, multiple operator core network. So MOCN is taking the private network into the next stage of assuming a shopping center already installed its own private network. And when a shopping center is installing its own private networks, we are going to be able to rent those private networks to other operators. So if we take the shopping center as an example, the shopping center will deploy enough small cell, maybe on each floor, maybe few small cell in a floor, depending in some RF planning, exactly the same way that the shopping center will deploy DAS. Small cell will be cheaper in pricing, but it's a deployment that you need to do indoor. But when I'm deploying a small cell, I can create multiple networks on the same small cell. And the MOCN allow multiple core operators to use the same small cell, meaning Verizon will publish the Verizon network name on the small cell, T-Mobile will publish T-Mobile name on the small cell, and AT&T will do the same. So companies that wants to create MOCN take a MOCN gateway, connect all the small cell to the MOCN gateway, and connect the MOCN gateway to multiple operators. Expensive solution, take months upon months to connect because it's a VPN between operators, and on top of the VPN you need to run the S1 interface, but it's working and it's solid, and it's a very good way for an operator to get a piece of a network that a small cell is creating. So when AT&T will connect to a MOCN gateway of Hilton Hotel, assuming Hilton Hotel will create private networks in many of the hotels, AT&T will be able to have their own network indoor with the 5 bars and with the ability to give service to the AT&T user, to the AT&T cars, meaning cars that are using the AT&T connectivity, and also to scooters that are using AT&T connectivity. So any IoT device that is already using the AT&T connectivity can also benefit from this indoor coverage. So one second. I see a question. Let's see if it's relevant and we can answer it immediately. I see the question, we'll answer it in the end. So the MOCN, the MOCN gateway that is interconnected to multiple operators is not a simple task. You need to sign agreement for MOCN hosting with an operator, and then you need to create a VPN. So you need to be in the right place in terms of connectivity with other operators, and then you need to have also the right relationship. If a small shopping center out of nowhere will want to sign a MOCN agreement with operator, it will be very hard to get. But if multiple venues will want to sign agreements with operator, provided that they have the good brand and enough coverage, operators will do that. So the MOCN way is very popular now in terms of more and more companies are deploying networks, and operators are looking for ways to utilize this network. And the engineer approach to doing that is the MOCN way. Then there is another way, and we call it roaming. And you will see in the keynotes today that we think that roaming is a better way to solve the same problem with even more benefits. And in the roaming way, the situation is the same. I'm installing small cell in my branch. My branch can be a Starbucks coffee shops or shopping centers or hotel or whoever needs private network, and it's cost effective now. And when I'm installing the small cell, I will have my own network. So the biggest benefit for me to do the small cell is to have my own network, and my devices will be able to connect to my own network. But then on top of that, I will have the edge, because when I'm creating my own network, I can also use edge, and my devices will use the edge in the network. By the way, it was the same thing of the example before. When I'm creating a network, I just forgot to mention, but when I'm creating a network for myself, or as a hotel or as a shopping center, all my cameras and all my devices are already on the private network, and that's not a question. When I'm creating a network for myself and I'm putting all the devices on the private network, I have also another ability. I have ability to bring guests to the network. A guest can be a Tesla car. So a Tesla car can come to my network. And when I'm doing roaming solution, I have two ways of giving them support. If the Tesla have, let's say, an AT&T SIM card, I can register the Tesla in the AT&T network. And I'm doing it in a roaming scenario. When I'm doing it in a roaming scenario, it's not an engineering decision like it used to be on the MOCN. It's more a business decision, exactly like AT&T are signing a business roaming agreement with Vodafone. And when I'm landing in Spain, I will get into the Vodafone network. So when my car will get to a place of coverage of a private network, assuming we have the roaming agreement, I will be able to get the car to register on the private network. And then on top of that, what I will be able to do, because the car is only registering in AT&T network, the car will be able to get connectivity from the edge, meaning connectivity from the private network. And when the car will get connectivity from the private network, it will get all the bells and whistles of a private network, meaning low latency and higher throughput. So to create a roaming solution, what we need to do, it's not as complicated as to create a MOCN solution. We just need a signaling interface to an operator, and it's not an S1 interface. It's less complicated, and it's more popular for operators to create roaming agreement. By the way, there is a mistake in the slide. This is not MOCN gateway, because now we don't need a MOCN gateway. Sorry for that mistake. So we don't need a MOCN gateway. We need a core, and we are connecting the core to the operator in a roaming agreement. When we are doing that, we are able to do a few things. Now we can take a new vendor. Let's say Tesla have their own core, or some other company that have SIM card. And now the cars can do roaming on the private network, even without the operators. And this is something that we are going to see more and more in private networks. We will see situation in private networks that a company like Starbucks create their own private network, and then the point of sale of the Starbucks provider will do roaming on the Starbucks network. So we will see situation in roaming on private network when the user is not necessarily an AT&T user or T-Mobile user or Verizon user. The user can be a car, the user can be a scooter, the user can be a device that got identity, and this identity not necessarily belong to the mobile operator. And this is part of the big reason why we are big believer in roaming. We are big believer in roaming because it's easier to deploy. You can get the edge, and the ecosystem become bigger. More and more companies that have their own network can start sign roaming agreement with other companies that build coverage. Let's pause here and talk a little bit about edge and why we think it's relevant. And it's very relevant in the context of how a more futuristic use cases are going to be available for us. And everybody loves edge. Edge is the new kids in the block. AWS have edge, Azure have edge, and more cloud providers starting to offer edge capabilities. Edge allow us to have a better cloud, less centralized cloud, low latency, data residency will be very important, and the throughputs can be much higher. So edge is important, and let's see how we think a futuristic use case will mandatory roaming and will perform. So let's assume, all of us, that this is where we want to be. We want to get to a place. It can be a shopping center, it can be hotel, it can be any place that I am as a visitor is going to, but I want the digital aspect to be augmented on my reality. And while I'm getting that, I don't want to get seasick. I want it to work seamlessly. And if I'm moving the head right or left, I want to see the reaction immediately. So in that scenario, me as an AT&T user, I will probably have my iPhone connected to AT&T, and probably, hopefully, new glasses that will probably be connected also to AT&T. the new glasses that everybody waiting for, hopefully are going to be the killer application of 5G. So if me, as an AT&T user, with my new amazing augmented reality glasses and next generation phone is getting into a futuristic shopping center, the experience that I want to get is very seamless. I want to see exactly where I'm going. I want to get attention to whatever I need to get attention, and all of it needs to be on the glasses. So for an AT&T user with an AT&T glasses that have a SIM card that is connected to private 5G, we want to give low latency and we want to give this user experience. So in order for us to do that, when I'm getting into the shopping center, probably the company that invented the augmented reality ultimate shopping experience will deploy it in AWS and in the AWS outpost that is installing in the shopping center. But then when I'm getting into the shopping center, I can not get service from AT&T, because if I will get service from AT&T in the Mokan way, I will not get the low latency and I will not be able to be on this outpost. So when I'm getting to futuristic shopping center that have a futuristic application of augmented reality, I will need to enjoy from this edge. So I will need to, maybe I'm an AT&T user and the authentication will be to AT&T network, but I need to get service from the edge. I need to get service from the small cell. Exactly like when I'm getting to another network in another country, I'm getting service from this network and not always going back to my home country to get service from. So in these scenarios, edge is critical, and edge is going to be critical in anything from a car that need low latency to park autonomously, all the way to augmented reality with glasses and robotics and other devices that are going to be more sensitive to delays. And as the industry will develop, more and more use cases will be very sensitive to delay and to the data path. So with that in mind, let's kind of summarize all the ways that we can today give guest users some sort of coverage. And the coverage can start with, I just want a good reception, 5 bars. I want 5 bars, Wi-Fi, maybe at least from our experience, was never a successful solution. DAS absolutely give 5 bars. Mokan absolutely give 5 bars, and Private LTE absolutely give 5 bars. But then let's talk about low latency. Low latency you cannot really get from Wi-Fi. With Wi-Fi you cannot get anything. Maybe on paper, on Wi-Fi offload, you are getting data from the actual access point, but nothing is manageable. On DAS, you don't really get low latency, and in Mokan, you don't get low latency because you need to go back and get service from your own service provider. On roaming, you can get low latency. You can connect as an AT&T user to the hotel network, and you can still be on the edge of the hotel network. Seamlessly, Wi-Fi is completely not seamless. All the cellular technology are absolutely seamless. I don't need to do anything to get connectivity. SLA, which is very important when you actually deploy a private network, you want to be able to configure who is getting more service, who is getting less service, and both on Mokan and roaming, you can support that. And then complexity. Wi-Fi, it's not complicated to create. It's not complicated to even connect to operators. DAS, more complicated, more expensive. Mokan, very complicated. I saw a question here if we are already connected as Mokan to other operators. So the short answer is no, because it takes time and it's an engineering way to solve problems. But roaming is not an engineering way, so it's not complicated, and the answer for roaming is that it's much easier and yes for some operators. Then there is a question, who is my user? Both on Wi-Fi and on DAS, sorry, on Wi-Fi only the user phones are the user. On DAS and Mokan, you can have the people are users, or you can have the IoT device a user. On Mokan, you can also have your own internal users because you already created a network for yourself. And in roaming, you can have all the above, and also you can sell IoT to other vendors because you don't really need to connect only to operators, so you can sell it to others. The last thing, which is the great benefits of cellular and not exist on Wi-Fi, it's mobility, and it's the ability to move between different private networks or between public and private networks. So just to summarize the pro and con of each technology. So with private networks that are developing and becoming more and more reality, we think that there is some sort of evolution in the market, and the evolution that we saw that kind of happened in other industries, in the telco, is getting to the connectivity side of things. So if this conference call 10 years ago would probably not be on Zoom, would probably be on some incumbent network, some conference lines of one of the operators, 10 years, maybe less, and I think 90% of the conferencing today is not powered by operators, meaning there is a new age of service providers that are very vertical specific. We are a service provider just for conferencing, and service providers that are very vertical specific can give an amazing user experience, and while giving an amazing user experience, they can take market share. So it took 5-10 years to developers to completely dominate the conferencing operators. And today, operator for conferencing is not the incumbent. Similar thing happened to messaging. Yesterday, WhatsApp, iMessage, Twitter, and other applications completely dominant now messaging, and create a situation that most operators today don't really make money out of SMS. So in the communication, what we see that happen, that developers created brand new service providers that are very vertical specific. Some for messaging, other for conferencing, and the vertical specific service provider are not incumbents. The vertical specific service providers are companies that are solving a problem, and they are doing it in a developer way. So if I have tools to get cloud compute, and if I have tools to get API for telephony, I can become a service provider for video conferencing, or a service provider for messaging, or the new age CRM. I remember in the old days, to connect CRM to a phone system, so when the agent is answering the phone call and he will see who is calling, was a nightmare. Today, it's like companies like HubSpot integrated everything, including the voice and the recording and the transcription into one solution. So we see a shift in service provider from the service provider of the past that used to buy license and provide service, to the service provider of the future, which using APIs and create a vertical specific. So if we saw it happening on voice, we saw it happening on messaging, now we are going to see the same transformation in connectivity. So now it's the era when service providers for connectivity will start to be different than the legacy, especially on private network. And you know, it sounds like we think the legacy is the mobile operator, but that's not exactly correct. The legacy on private network is companies that are providing Wi-Fi to enterprises. And companies that provide Wi-Fi to enterprise today are kind of one solution fit all. So Cisco, Meraki, or Aruba, or other Wi-Fi don't distinguish between different vertical needs. They have a solution, you need connectivity, and it's not important if you are a shopping center or if you are a hospital. And they are really dominant in the private networking space. So regardless if you're a hospital or a campus or shopping center or hotel, today your option is one. You get Wi-Fi and you get the same coverage. Nobody really cares that the users in hotels are one type of connectivity, with one type of connectivity needs, and the user in shopping center is with a different connectivity need, and university, the density is different and the needs are different. So today there is no really vertical play on private networks. There is no really companies that are specialized in one thing. It's like I will tell you that companies that can build hotel can also build a college and can also build hospital, but it's not true because each one have completely different best practices. And we think that now with private network, with regulation, and especially with 5G and slicing and all the bells and whistles, that I can really tailor the connectivity around my need, we'll see a new era of solutions that are more vertical specific and can solve the problem completely. And the problems can be various. If I'm a car company, I probably need lower latency and edge and some security. And maybe sometimes I need to be energy efficient, and sometimes I need to be able to control latency. Sometimes my user will be only IoT devices, and in other time my users will be roaming users. So to be able to have different type of quality of service and different types of users on a network, will allow customers to tailor the solution much more. Let's take an example. Let's take hotel as an example. And hotel network can easily decide to move to private network or private 4G or private 5G. And by deciding to move to a private network, let's see how a play like that will roll. So the hotel will have radios. The radios can be indoor or outdoors, and we'll have some sort of cloud to manage all the branches. Big benefits of cellular, not like the Mirakis and Arubas of the world, but you have complete flexibility. You can choose any radio you want to manage any with any core that you want, because it's a protocol base. It's not a solution base. And then when the vertical hotel service provider will create it for hotels, now we are talking about who is the customer. The customers can be the traditional one, all the cameras in the hotel, all the point of sale, all the doors, all the alarms, all the fire sensors. The customers can be also a Tesla. I'm taking Tesla as an example, but any car that is coming to the hotel needs to go to -5, get reception in -5, register in the network, and park autonomously. The customer can be a scooter that is coming to the hotel as a guest and registering maybe on AT&T network because the scooter is an AT&T user. The customer can be, again, me with my amazing smart glasses and my amazing phone to get local breakout. Sorry, let's be honest, the local breakout is from here. To get local breakout and to be able to see where I'm going in the hotel without asking 5 people, where is my meeting room? True story. So we think that hotel networks need is completely different than a hospital network need. Different devices, different SLA, different CPEs, different go-to-market, different problem you're solving. And slowly, we'll see more and more use cases when organizations, it can be in the beginning, the big guys, and later on, smaller players that will start to create a private network that are more specific for their need. They will take the part of the network that they need for their own users. It can be cameras and sensors and point of sales and the stuff. And then the rest of the networks, they will be able to resell to other operators or to resell to other IoT service providers that are guests in their network. So with that in mind, we kind of finished what we have to say about private network. We do think that more and more use cases will nobody knew what will be the killer application of 4G. And now we know that it's completely revolutionize the way we consume services. And on 5G, the same thing, maybe augmented, maybe self-driving, maybe others. But we know that the network needs, it's very important, and developers are going to show us what they can do with this type of networks. So just to advertise ourselves for a little bit, we are a cloud. We can completely host services that we spoke about today. We can do it in the MOCN way. We can do it in the roaming way. In the MOCN way, it's more complicated in terms of relationship with the operator, but it's completely doable. In the roaming, it's easier. And Monogoto as a cloud is built for developers, because we are betting on the fact that developers will take these amazing capabilities from the network. Sometimes it's just private, sometimes it's public and private, and create nice use cases. Now, let's see if we have questions. So I see a question here if we already have a signed MOCN agreement. So the answer is no, but it's a progress, and we are already in discussion. US operators are open to do it if the customer is UPS, if the customer is the Hilton Hotel. US operators will eventually do it because we know the US. So eventually companies like Monogoto and probably a few others will have a master agreement, and then we'll be able to bring more and more roaming to the MOCN network. I can say that it's easier to do it with roaming rather than with MOCN. 1 second, reading the other question. In roaming, do we need all devices to support CBRS spectrum? So to the CBRS spectrum question, when you create a private network, you can create it in the US on CBRS. You can create it also in the US on 900 megahertz and a few other frequencies. And yes, you need the devices to support it. So we already know that some car companies already have devices that support CBRS, and Qualcomm is with a big push for CBRS to be supported on their devices. Then there is a question if Apple and Samsung enable VoLTE. So Android is easy. Android, it's possible to enable VoLTE on private network. On Apple, at the moment, we don't have a way to enable VoLTE, and that's a big barrier. So when you are enabling private network, maybe we will be able to do it without data and without voice, sorry. And it's a limitation. Next question. Can I confirm that CAT-M and NB-IoT is working on CBRS? No, CAT-M and NB-IoT cannot work on CBRS because CAT-M and NB-IoT is an FDD. We can do CAT-M on the 900 megahertz, and we can create private network on the 900 megahertz. When create a private network on the CBRS, CAT-M and NB-IoT is not working, but CAT-1 is working. And we have an example of CAT-1 sensors that are very cheap compared to CBRS sensors that are being deployed. Last question that we have time for. Can you explain why you cannot have quality of service on DAS? The way we see quality of service is not by adding a repeater, it's by allowing different type of service. I have many more questions. I don't know if we have time for all of them. The way we see quality of service is by allowing multiple different use cases on the same network, and with DAS, in our view, it's harder to create this situation.
Okay, guys, thanks for your questions. Oh, do you want to?
Yeah, 1 second. I'm trying to see if we have time for one more question, Liran.
Yeah, we have a lot of questions and only a time for a few.
Yeah, do you have your own EPC? Let's take 2 more questions, and we promised we'll take everything and answer it offline. Do you have your own EPC? Yes, we have an EPC on the cloud, multi-tenant, and we have the ability to have edge meaning part of the EPC to run locally on the edge. But we are not selling it as an EPC, we are a cloud vendor. Which radio vendor are you using? One of our unique selling point, I would say, is that we are agnostic to the radio. So we can connect to any radio that the customers will want us to connect if the customer come with his own radio. And we have more than, like in our website already, more than 7 different integrations with different radio. 5G, it's just harder to get radios, and it's just almost impossible to get CPE, but in terms of our core, we are already there. eSIM. Yes, eSIM will work, and also non-eSIM will work. So any completely agnostic to the SIM side, we can supply eSIMs, and we can supply also physical SIMs.
Okay. Thanks, guys, for your questions. We would be happy to answer them after the webinar. You can send us your questions. We'd be happy to answer. Thanks, everyone, for participating. Thank you, Maol, for this very interesting session. I hope everyone had a good time today and enjoyed, and it sounded very informative. You will all receive a recording of the session afterwards. Thank you again, and hope to see you soon in our next webinar. Have a great day.